Investigation 5, Energy Transfer. In Investigation 5, we'll be learning about energy transfer by mixing water. And the activity that we'll do in class looks similar to what you see here on this page. I will have you get 2 cups of water. 1 cup will be at a certain temperature. This picture shows 40 degrees Celsius. And another cup will be at, this picture shows 60 degrees Celsius, but what we use in class probably won't match that exactly. And we'll simply take and mix them together and see what happens, or see what temperature they result in as they're mixed together. And it's not only the temperature, the final temperature that you get when you mix the water. I want you to be thinking about what's happening at the particle level. So this is Investigation 5. The goal of this investigation, and I want you to write this in your spiral notebook, the goal of Investigation 5 is to learn one way that energy moves and understand energy transfer as changes of the kinetic energy of particles resulting from collisions. Collisions means particles slamming into each other, bumping into each other. So once again, we're focusing on kinetic energy of particles and what happens when they bump into each other. And particles, we've learned about particles in terms of solids, liquids, and gases. And we also learned that liquids and gases are very similar. They're both referred to as fluids, and their particles are similar, and they behave similarly. And we also talked about in class how solids are a little bit different because of how tightly packed together their particles are. So pause the video and put down the goal into your spiral, and then when you're done, you can hit play on your video again. The science notes that I want you to get down in your spiral start here, and there's not too many of them, but these are the main takeaways I want you to know from Investigation 5, and a good way to remember these is to obviously write them down, take notes. So number 1, mixing water of 2 temperatures results in water of an intermediate temperature. Intermediate. That means it's somewhere in the middle or between the two temperatures of the water that was mixed together originally. And you can reflect on this after doing the lab in class. You'll be taking these notes after you do the lab, so it'll make more sense to you. Number 2, substances heat up or cool down as a result of energy transfer. Any substance either heats up or cools down, not because it's getting colder or getting hotter. We can't say, oh, it's getting colder, so it's heating up, or it's cooling down. It's getting hotter because it's heating up. All of this happens because energy is being transferred. And we've learned about kinetic energy, energy of motion, and we've really tied it closely to talking about particles. So, substances heat up or cool down as a result of energy transfer. Another thing to remember is that hot always flows to cold. Heat transfers. So heat flows due to several things. One is conduction, one is convection, and one is radiation. And I have a picture in this short video so you'll understand these. It's coming up. So substances heat up or cool down as a result of energy transfer. Pause the video if you need to, and then hit play when you're ready to move on. Note number 3, energy transfers between particles when they collide. Energy transfers between particles when they collide. So things heat up or cool down as a result of collisions of particles. Number 4, Energy transfer by contact is conduction. So whenever you have something touching something else, you have energy transfer by conduction. Number 5, energy always transfers from particles with more kinetic energy to particles with less. Energy always transfers from particles with more kinetic energy to particles with less kinetic energy. And that's why I have this picture here once again, is for you to understand that hot, no matter if it's a solid, liquid, or gas, always transfers to cold. And heat energy in this case, flows due to conduction, convection, and radiation. Now if we look at this picture here, this is the one I want. If we look at this picture here, I've said several times now, conduction, convection, radiation. Conduction is energy transfer by touching. So I think they put it here because your hand would be on the pot, and the energy from the flame goes to the pot of water, and then it would reach your hand because your hand's touching. Radiation is the transfer of energy through space. Okay, so you've all been at a campfire where your hands are not in the fire, but you can feel the heat energy from the fire reaching your hands. So this is what we refer to as radiation. And then convection occurs in the pot of water, whereas the water particles gain kinetic energy, they rise, right? They rise because the space between the particles increases, and then as they get at the top, they start to cool, so they'll fall. So you have what you call a convection current. Hot rises, cold falls. Hot rises, cold falls. And we talked about when you swim in a lake, you can sometimes feel the current. You can feel the current. The water at the bottom feels cold because it's fell from the top. Then as it heats, it rises again. So you have the same thing when you make your macaroni and cheese. Okay? So the big thing is energy always transfers from particles with more kinetic energy to particles with less kinetic energy. Note number 6, energy is conserved. What does that mean? It means that energy in a system does not change. The amount of energy in a system doesn't change. No energy is ever created and no energy is ever destroyed. It just merely moves from one place to another. So if I was driving to school this morning and it was 7 below, and I take my hands and I grab my steering wheel, energy is transferred from my hands to the steering wheel. My hands are warmer than the steering wheel. So that heat energy goes from my hands to the steering wheel, and the steering wheel actually heats up. And if the steering wheel heats up, then my hands cool down a bit because they've lost some heat energy to the steering wheel. And we'll talk more about this. Note number 7, temperature is measured in degrees Celsius. It's metrics. In the USA, we use Fahrenheit, but in science in the US, as the rest of the world, they use degrees Celsius. Number 8, temperature is a measure of the average kinetic energy of the particles of a substance. The average kinetic energy of the particles of a substance. So a thermometer will measure, in this case we're looking at gas. Okay, we're seeing gas here. And here's the bulb of the thermometer, and it's full of alcohol, right? And as the bulb gains energy, the alcohol will rise. It'll expand. The particles move faster, gain kinetic energy, and the space between the particles increases, so we get expansion. And then the opposite would happen if you cool the gas around the bulb of the thermometer. The particles would lose kinetic energy and they would contract. So the alcohol level would go down. So temperature is a measure of the average kinetic energy of the molecules, or the particles, I like to say for 6th grade, around the bulb. And this can be measured not only with gases, but liquids and solids. Note number 9, equilibrium. It's a big word. Equilibrium occurs when all parts of a system are at the same temperature. So if you mix hot water with cold water, you mix them in a separate container, at some point the particles will all be moving at the same rate. And we call that equilibrium. It's when all parts of the system are at the same temperature. They're at the same temperature because all the particles are moving the same speed. And last but not least is note number 10. How do we measure heat? Well, many of us would say, oh, we measure it with a thermometer, but heat is actually measured with calories. And you've heard of calories. Don't eat that candy bar. It's got too many calories in it. Well, a calorie is a measure of heat. And 1 calorie is the amount of heat needed to raise the temperature of 1 gram or 1 milliliter of water 1 degree Celsius. So calories, you have to take calories into your body so that your body can create heat. Okay? So it's kind of interesting. And you'll get more of that in high school. So you have your 10 notes. One last item, in addition to the 10 notes that you have written into your spiral, I want to go over energy transfer in a different way here. Energy transfer. Now let's pretend that I have, let's say we're talking about water, and I'll use blue to represent cold water. So I'll write blue is cold, and we'll say H2O hot. Alright, so if I have 1 particle of cold water, that's 1 particle that still has 2 hydrogen and oxygen, 1 particle, and then 1 particle of hot. How are these 2 particles different? Well, we know that cold means less kinetic energy. That particle has less energy than a hot particle. Hot means the particle wants to move faster. So if we were to show how a blue particle would move, and let's say I was going to draw a line, that's the path the blue particle will move, and this is the path the red particle, or the hot water, will move. This is what it could look like. The blue would move slow. The blue would move slow because it has less kinetic energy than the hot. And the hot would move fast. Fast. Slow. Fast. Well, we've talked a lot about the word collisions. Collisions have to do with energy transfer. So when something collides, that means they hit each other, they bump into each other. So what would happen if we had a slow moving water particle hit a fast moving particle? Let's pretend they both hit. We'll still have 2 particles as a result, but they won't be necessarily cold anymore, and they won't necessarily be hot. Why is that? So when the particles hit, we'll use color to show that they have a different amount of energy. Well, how did energy transfer? Well, energy always transfers from hot to cold. Hot is transferred to cold. So more kinetic transfers to less kinetic. So hot transfers to cold. And we have two particles that we would now say are intermediate. And that's energy transfer. And that is energy transfer. And that is what we saw when we did the mixing water lab in class. If we could look at particles again, we saw the cold going slow and the hot going fast, and we end up with an intermediate. The cold particles gained a little energy, and the hot particle lost a little energy, and it's called an intermediate. So this is the end of the video, and I hope it has helped you understand energy transfer. Make sure you have the goal written down. Make sure you have the 10 notes.